Good morning. Today we come to the first lecture of the second week, and we are going to just see the introduction to Drawframe today. And most of it is going to be the videos that I'm going to show you so that you get acquainted with the machine. So let's begin. Let us just first look at what a Drawframe actually looks like. Up till now we just know the concepts of drafting, doubling. So to complete all these objectives, what exactly is required in the construction of a draw frame? So first let us take a look at the modern draw frame, and then we'll discuss as and when wherever I'll stop the video and maybe explain wherever required.
Drawing's main purpose is to further align and parallel the semi-oriented fiber from carding. In accomplishing this, blending or doubling is also achieved. From 6 to 8 card slivers are combined to be fed to the initial drawing process, sometimes called breaker drawing. A series of pairs of rollers are used to reduce the multiple slivers being fed back down to the approximate weight of one sliver. These roller pairs consist of one rubber-covered top roller and one fluted steel bottom roller. Spring or air-generated pressure is used to hold the slivers firmly. There are surface speed differences from the back pair of top and bottom rolls to the front set, with the back pair turning more slowly and gradually building in speed through to the front set. This mechanical speed difference and the slipping action imparted to the gripped fibers is called draft or drafting. This is where the drawing process gets its name. The machine draws out the slivers being fed and reduces their total weight back down to the approximate weight of one sliver. In doing this, the trailing ends of the gripped fibers, which may not be completely straight, are straightened out by the slipping and pulling action imparted to them. As the drafted fiber web exits from the front set of drafting rolls, it is condensed back into sliver form using a trumpet-like device, and the resulting sliver is coiled into a can. Once again, this is for temporary storage and for transport to the next process. Depending on what spinning system will be employed, the end product, and other process considerations, the output sliver from breaker drawing may be drawn once more, called finisher drawing, or it may be used directly for the spinning process. This is the point that the breaker drawn sliver may also be directed to the combing process.
Okay, so we have just seen the process. Maybe just an introduction. All of the points that he has just mentioned, I will be covering all of them in the coming lectures. So let us first see the objectives of any draw frame. Any draw frame by the method of doubling would reduce unevenness or mass irregularity. We have also seen how it is able to do it in our previous lectures. During the process of draw frame, there is something called as drafting, which we have learned earlier, and which leads to parallelizing or straightening of fibers. So that would be our second objective. Draw frame also is capable of removing entanglements during drafting. There will be some entanglements present in the card sliver which is being fed to the draw frame, and those also can be removed or reduced after drafting. Draw frame has got one more objective, which is blending. And in blending, maybe if we want to blend two different fibers, polyester and cotton, for example, we would blend them in 67-33 percentage. So we would be just feeding 4 slivers of polyester and 2 slivers of cotton, and we would get a 67-33 blend here. So blending can be achieved on draw frame. Blending can also be done at blow room stage, but since we are learning draw frame, one of the objectives of draw frame could be blending. Also, I will explain slightly in more detail in the coming slides how draw frame is a ideal machine for removal of micro dust. The larger trash particles we have already taken care of in blow room and card, where they are removed. But when it comes to micro dust, which is very very difficult to remove because they just stick to the surface, and these dust particles, micro dust, create a problem in processes like open end spinning, which cannot tolerate even 0.05% of dust particles in them, and they would lead to a lot of end breakages on that machine. So micro dust removal is one of the important objectives of Drawframe. It has been found that in Drawframe, due to a lot of fiber to fiber friction and fiber to metal friction during drafting, because during drafting what we're doing is basically we are pulling the fibers against each other, and because of the friction the micro dust is released into the atmosphere around it. And if we are able to apply some kind of suction around at this place, this micro dust removal becomes easy. Otherwise, if there is no suction, this micro dust is released into the atmosphere, and it'll remain there in the department for a long time. So it's better that we are able to close that drafting area, and apply a sort of suction which could remove all this micro dust as soon as it is released from the fiber surface. So these are the 5 objectives, and we come to the point where we already know this. The draft and the doubling values are usually the same. We have discussed this in our previous lecture. Um, Normally it is 6. Draft and doubling is 6 for short fibers, and it goes up to 8 for longer when we are processing long fibers. So this is explained by using pictures here, the objectives. The first objective, one of the objectives that we saw was removal of entanglements or other hooks by drafting. In the video we saw how this fiber enters. This is a small picture that I took from the earlier video, where the fiber enters the drafting system, and as it is being pulled by the next roller, the fiber end is being pulled, and that's why it helps open up this particular hook which is at the rear end of the fiber. This is basically technically would be called as trailing hook, and whenever the time comes we'll see them again trailing, leading. We have learned them in carding, but if required maybe it will be repeated later. So this is one of the objectives that is explained. And the second objective that we know of Drawframe is reduction in mass irregularity, or we can say improvement in the evenness. So let us just, this is one slide which I have just, for explanation, I have taken it up from the NPTEL site, which when you can visit and take a look at their lecture videos. So in that, sir has explained how the mass irregularity is reduced. So if there are, suppose say n slivers which are combined, and each having a mass variation of say sigma 1, sigma 2 and so on, say sigma n, then what happens is variance statistically has got an additive property. So the total combined variance would be square of individual variances of all the slivers. So for example, if there are 6 slivers which I am feeding, then it would be sigma 1 square to right up to sigma 6 square. All of it added together would give me combined sigma square for the output sliver. So when you solve this, it becomes, the equation looks like this. Sigma I raised to square I is equal to 1 to n, and when you take it, it will become sigma square here into n. Why this all sigma becomes sigma, just sigma, and not 1 2 3 4 5, is because we are getting the sliver from the same source, that is the same card, and that's why the variance of that material which is coming from the same card would be almost the same. So I can easily replace 1 2 3 up to 6 maybe by, say, straight away by n, and I would get this equation. Or if I were to simplify further, it will be sigma c is equal to square root of n of sigma. So you come to the next slide, where m, if we assume m as a weight of weight per unit length of each sliver that is being fed, then in that case CV of the individual fed sliver would be that CV is equal to sigma upon m into 100, and CV of the combined sliver would be root n into sigma upon nm into 100. Now if I were to separate this part and write it like this, then I can easily replace this with CV of individual here upon root n. So I would get this equation. And once I get this equation, we can see that the CV combined is going to be less than that of individual. So it proves mathematically that the CV of the combined output sliver that we get is going to be much less than that of the individual slivers. But if you plot a graph of CV as you keep on increasing the number of doublings here, we see that the output CV initially reduces, but then later on flattens out, and therefore increasing the number of doublings beyond a certain limit does not really help, which we have learned in the previous lectures by a different method. Say it was not mathematically proven, so here is a mathematical proof of how the CV of the output sliver is reduced. So rate of change of CV of the combined sliver decreases with increase in number of doublings. Hence, doubling beyond 6 or 8 does not help much in improving irregularity. In doubling, thick and thin places in the sliver coincide and compensate each other. Too many slivers increase drafting force and increase the chances of fibers getting plucked from back roller nip in bunch form without real drafting. So this is what happens if we go on increasing the number of doublings. What happens is, because there are too many slivers, there are chances that the fibers just get plucked without really being drafted. So these were the two objectives which we just saw. The next objective was blending. So blending can be explained in the form of a picture like this, where we have the slivers from different sources. They are basically shown as in black and maybe without any filling here. So 4 of coming from one source, 4 coming from the other source. And if this was the drafting system where it gets drafted, the drafted slivers would look like this. This is the first stage of Drawframe. And if this particular output can from the first passage of Drawframe, I were to again pass them in the second passage of Drawframe like this, 1, 2, 3, 4, 5, 6, 7, 8 doublings. What will happen is each can would be having a part of both of these types of slivers like this. And after this, whatever output I will be getting, it will be a more homogeneous sliver with a better blend. So this is what we are trying to achieve here. So this blending or mixing is achieved due to doubling of slivers. If I assume 8 slivers containing black and white slivers side by side, after drafting each sliver, it will become thinner by 8 times, if the draft is 8 of course, and will emerge as a thin ribbon from the nip of the front ruler. So once you bring them together and compact it and form the final sliver, it will contain all 4 of white and black as well as 4 of white ribbons. It will get consolidated. So now we have seen the 3 or 4 objects that the Drawframe has. So we come to the last objective, and that is removal of dust. So for that, I would like to show you a video where you'll be able to understand how it is really helpful in removing micro dust. Okay, so this is the creel that is shown here. We'll see it in detail later. The slivers are being fed. You can see there are 8 slivers being fed, that means doubling is 8. This is the auto leveler, which we will learn in depth. Here there is a drafting system which is shown, which is the 4/3 drafting system, and these are the calendar rulers. These are scraper bars which are scraping the top rollers. Whatever fly dust gets stuck to these rollers. They are scraped here, they are collected here, and once in a while these paper bars are just pulled back, and whatever gets collected here is being sucked by the suction system. So this entire area remains clean. So this you can see, this is the kind of fly and dust which is being collected, which is removed. Then we can see this is the calendar roller, and here we see the various diagrams showing CB. Then you will have a spectrogram. It also gives you thick places that are there in the sliver. And this is a delivery can where the sliver gets oiled neatly. And here you can see that a can changing is taking place. The next can is being filled. This is the tube for coiling which is shown. And this particular, the right hand side one is an improvement over the previous one. Just a little bit of shape is changed here, and we see a lot of difference in the conventional. The fly or the dust gets accumulated in this area, whereas it does not. If it were to get accumulated, it would give you a sort of the bunch totally comes out and it is seen on the output slider. Here now we see how the new new can is put in place of an old filled can. So what happens is we are stopping the drafting system, and then this is calendar roller runs. It will create a thin place, and after that again the drafting system is put in place, and this particular thin places come here, and the new can is being replaced. You can see this is the automatic can replacement system. It's already like this is auto leveler. You get to see directly the speeds, the CV, the spectrogram. The spectrogram helps us in identifying the place of fault or the error, and easily then the personnel can go and rectify or fix that fault. Also, we see that in the modern Drawframes, the setting of the rollers, this is setting that is happening. Again, this we will learn in detail later. The setting of the rollers is very simple. By just using the Allen key, you will be able to set the rollers for their distance between the two rollers. This is we have seen yesterday that we need to set it as per the effective length of the fiber that we are going to process. Drawframe has been opened. Here, if I want to change a belt, it is again very simple. See how simply he is just removing that belt, loosening it, removing the tension on it, replacing it with a new belt, and now he will just tighten up by applying some amount of tension. It is easily replaceable. So you can see the speed here, 1100 meters per minute. Get all the data, even lubrication intervals are seen here, whether it is due, whether we need to do it, when is the next lubrication scheduled, and so on. So this is one of the modern Drawframes by Ritter. So after we have just got a little bit of idea of how the various objectives of the Drawframe are achieved, we come to the next slide where we see the processing lines. I would ask you to concentrate more on the last two here, because the first three are for open-end spinning, which will come, this portion will come for you, it will be taught to you in the higher semesters, maybe in the final year. So right now at this stage you need to just understand these two process lines. This one, the second last one is for making carded yarn, and the last one is for making a combed yarn. So let us just see how the machines are put up in a sequence. So first one here in on before both of these, of course, there is going to be a blow room, and after blow room, the material comes to the card. From the card, there will be two draw frame passages, the breaker and the finisher, and then it goes to the roving frame, and the last one, that's the ring frame. It's all labeled out here. So this particular process line, if you follow, what you get at the end is the carded yarn. And if you follow this last process line, you will get what is at the end, you will get a combed yarn. So this process line we'll just study. After blow room, when it material will come to the card, then you will have one passage of draw frame, after which you will have some process which prepares the material for the comber, which is the next machine. So there is going to be, after draw frame, a combing preparation, then a combing machine, and only after that it will go to another draw frame passage if required, and then it will be passed on to the speed frame and ring frame. So this is the process line that you need to follow if we are making a combed yarn instead of a carded yarn. So let us see who are the major players or the major machine manufacturers for the spinning machines. The first name that comes is the Rieter, and the second major competitor is Trutzler. So both these machine manufacturers are major companies in the spinning industry. So let us just take a look at both of them. Just a little bit of background about them. This Rieter is a world's leading supplier of systems for short staple fiber spinning. Based in Winterthur, Switzerland, the company develops and manufactures machinery, systems, and components used to convert natural and man-made fibers and their blends into yarns. So let us look at Trutzler. So Trutzler has been building machines for spinning preparation since it was founded in 1888 in Germany. Today, the company is recognized as technology and market leader for openers, mixers, high production cards, draw frames, and combing. Whether cotton or man-made fibers, Trutzler stands for innovation, quality, and economic efficiency. So, after looking at these major machine manufacturers, let us take a look at the few of their draw frames. So first, let us look at the Rieter's draw frames and the kinds, the variety of draw frames that Rieter's has got to offer. So I have put in here some links which you can even go through later on. So let us just see what is there when you click on these links. So you will see the draw frame. It's a double-headed auto leveler draw frame. We'll see what we mean by double-headed. That means there are basically two deliveries that are there to this draw frame, and this draw frame also has a auto leveler included in it. So there is a video which shows this. So as you can see, this is RSB D26, and you see two delivery places here, and each one is being fed with 8 slivers each. What you see here is the filled can coming out. Also, we can observe that the machine, each machine side is independent, where while that is running, this can be stopped if you need to mend something or change something. So they are independently running independent of each other. So there are panels which shows as before CV, etc. So this is about the first type that Rieter has got to offer. So let us look at their model, which is RSB D50. This model is basically a single head, but with auto leveler, of course. So let us take a look at their video. So RSB D50 draw frame is a single delivery draw frame, as you can see. Again, there are 8 cans which are fed over here. Doubling is 8, that means. and you can see this can changing mechanism automatically how it is being done. This is an auto leveler which we shall study in depth later on. This is how the piecing is done. It's very simple. So this is about the second kind of draw frame that Treater has to offer. So we come to this third type, SVD26, and this, as soon as you take a look at the video, you'll see that this gives you huge delivery cans, and the can changing mechanism is a new one. As you can see, there are two heads to this. The doubling of 6. There's an indicator. There are indicators which show that it's time for can change, and you can see how neatly can changing has taken place. And just observe the size of the cans. It's above 1 meter, 1.2. So this is about the Ritter draw frames. So let us look at the draw frame that is offered by Tutzler also.
Hello everybody, welcome back. Today I'm going to introduce you with a new machine, and it's from Tutzler, Germany. And this machine name is TD Model 8, and it's 2016 version. We used to call it finisher because this machine is getting the raw material from Tutzler, another machine which is called Tutzler TD9. And yeah, Tutzler TD9 is supplying 8 can to Tutzler TD8 backside, and this can is transferring sliver, and this machine is taking the sliver and making a single piece of, single length of sliver for the another machine, and it's called simplex roving machine. And as you can see, that sliver is coming to the top of the machine, and it's getting inside of this machine head, and it will become another sliver, and it's just mixing because finishing the process of making sliver. The sliver is the first stage of here, and in the meantime there is a lot of quality machine that we used for making is more developed, that we can get 100% export quality here at the end of our process. So this machine is getting the sliver from 8 can, which is coming from Tutzler TD9, and you can see it's already inside of this machine, and it's passing through the mixing process, and it's making single length of sliver, and the sliver will store another can, which is calling the color section of this machine. And this is the advanced HMI display with this machine, and of course by this display, production man, electrical man, mechanical man, even the quality manager, everybody can put input value in here, and they will get exact result what they need. And this is the front side, and it's called the coiler section because the sliver is coiling inside of this can, and this can will send to another machine which is called simplex roving machine. And this machine is near to complete fill up this can, and when it's done, I think you already had a look on display, and there was like 3200 meter will be exact length when the process will complete, and it will change the can automatically. right now, and it's near to finish, and we'll get a signal, and within a couple of seconds it will remove the full loaded can and it will take the empty can for a recoil again. Yeah, it's passing through the full can, and it's already took the empty can and it's already started recoiling. And this is how this machine works, and in my next video I will show you what is the electrical function inside of this machine, and it's controlling, of course, this machine. And thanks for watching this video. Have a nice day. Bye bye.
Yeah, you must have observed that the cans have got wheels below it. All the cans, delivery cans will have wheels. So now, after looking at the actual draw frame, let us just go through the passage of material through a draw frame via this sketch. And there are very few parts that are involved here. What we need is just a drafting system, and all other parts are just required for feeding it, or maybe just collecting the output sliver and so on. So it's a very simple machine, draw frame. So we see the one that is marked here. These are the feed cans. Only 2 are shown, but there would be around 6 to 8 here, and they come from either card if it is the first passage, or if it is a finisher. This one is a finisher draw frame. Then in that case, these cans would be coming from a breaker draw frame. Then what we see is the feed roller, or rather the guiding rollers, which would just pick up these slivers from each can and try to feed them to the drafting system. So third is a drafting system here. Then what we have is a trumpet, which is a funnel shaped part of the draw frame, which will help in compacting the sliver. Then what we have is a calendar roller, which again helps in the compaction. And then there is this passage of tube gear. It will pass through the tube, coiler tube, and it will be coiled neatly into the output can, which is marked here as 7. So this is a simple passage of draw frame which we need to study. So now, after knowing the draw frame and the parts that are involved, let us look at this small overview of this retail draw frame video, where actually all the places, all the parts are, a few places are marked in the video, so it will become easier to understand. So this is the frame, as we marked here. So again, we study in detail. So here we see 8 double quick thread. This is actually the auto leveler, but it goes, the material goes into the drafting system further. This is the delivery sliver can area. Here what we see is the drafting action, which part of the video we have seen earlier. This is the 4, 1, 2, 3, 4 over 3 drafting rollers. Fly or dust is being collected here by the scraper that are there on the top rollers, on the top roller clearer. They are pulled back for some time, 15-20. As soon as the material is collected here, also sometimes the fly is out of the system. The dust chamber is called statistically. We see the coiler roller. We can get all this data in the PC screen or the panel. And how to use these spectrogram in our using the get thick places and get data also. That quality can be improved. This is the output can, this is the tray. Yeah, again this draw frame, how it works when a new can is supposed to be put in place of a full can. What happens is drafting stops for some time, the calendar will run, so you get a thin place created. Again the controllers come in position, and what we see here is that this thin place has entered the can, and as it is being pulled features which are shown. You can see the spiral flipping here. Now we have come to the end of this lecture, and what we have learned is the overall construction of the draw frame, and from here on we will go into each and every part in detail, and we will learn the reasons why why these parts are so important. We are going to learn the roller settings and how to analyze a spectrogram and so on in our coming lectures. So thank you very much.